Welcome to a journey into the heart of reasoning. In a world overflowing with data, how do we make sense of new information without losing our minds? The answer lies in a 250-year-old theorem by Thomas Bayes. Today, we focus on its most misunderstood yet vital component, the prior, or P of A. It represents your starting point, your bias, and your existing knowledge before a single piece of new evidence is even considered. Imagine you are looking for your car keys. You don't search the entire planet with equal intensity. You start with a prior belief. They are likely in the living room or the kitchen. This mental map is your P of A. In Bayesian statistics, the prior is the mathematical formalization of this pre-knowledge. It is the probability of an event occurring based on everything we know up to this point, but before we look at the current data. Why does this matter? Because humans are prone to the base rate fallacy. We often ignore the background probability of an event when presented with flashy new information. For instance, if a highly accurate medical test for a very rare disease comes back positive, the chance you actually have the disease is still surprisingly low. Why? Because the prior probability, the rarity of the disease, is so low that it outweighs the test result. Statistical mastery begins with acknowledging the base rate. Let's talk about quantifying the prior. It isn't just a gut feeling. We often use a beta distribution to represent our uncertainty. A beta distribution is defined by two parameters, alpha and beta, which you can think of as prior successes and prior failures. If you are 90% sure a coin is fair, your prior distribution will be tightly peaked around 0.5. If you have no idea, it might be a flat, uninformative prior, meaning every outcome is equally likely. There is a fundamental rule in Bayesian thinking called Cromwell's rule. Named after Oliver Cromwell, it states that you should never assign a prior probability of 0 or 1 to any event unless it is logically impossible. If your prior is 0, no amount of evidence, no matter how overwhelming, can ever change your mind. This is the mathematical definition of being closed-minded. Bayesianism teaches us to always leave a tiny window for being wrong. In the real world, priors are everywhere. Your email's spam filter uses them. It knows the prior probability that any given email is spam, around 50 to 80% for many accounts. When it sees the word free money, it updates that prior. In high-frequency trading, algorithms use priors based on years of market history to predict the next millisecond. The prior isn't an obstacle to the truth. It is the foundation upon which the truth is built. To master Bayes, you must master the art of choosing your prior. Is it informative, based on solid historical data like a Google search trend or a medical census? Or is it weakly informative, just enough to keep the math within reasonable bounds? As we move forward in this series, remember, new evidence doesn't replace what you know, it updates it. The prior is where your story begins. In our next video, we will explore the likelihood, the engine that powers Bayesian updates. We will see how to measure if the data actually fits your theory or if it contradicts it. But for now, check your own assumptions. Are your priors based on facts or just feelings? Thank you for watching. References: E.T. Jaynes, Probability Theory, The Logic of Science; Richard McElraith, Statistical Rethinking; Nate Silver, The Signal and the Noise.